Hello and welcome to the first double-digit webinar, webinar number 10 from Dyalog TV, titled Isolates in the Cloud. I'm going to be looking at some work we've been doing in preparation for version 17 of Dyalog to enhance the Futures and Isolates framework that was released with version 14, I think it was, so that you can do parallel processing and hook into processes running on the Amazon cloud. As usual, there's a chat. If you're following this on Dyalog.tv, there is a monitored chat, and questions will be posted to me with a bit of a lag. I'll try and answer them. There should be some nice long pauses naturally in this presentation as I fire up virtual machines on Amazon. So try and spot those and slot the questions in at the right time. I'll try and give you a bit of advance warning. I should say before I start though, everything that's been done here actually also works with version 16.0 if you get hold of the isolate workspace that we distribute with 17 when it comes out in a couple of months' time. Right, so I'm going to start with a reintroduction to Futures and Isolates. I think there are probably some people who could do with a refresher, may never have heard of them at all. Then I'm hopefully going to be able to show you how to, starting from scratch, build and launch a Linux virtual machine with Dyalog APL on what Amazon calls the Elastic Compute Cloud, or EC2. I'm then going to launch 20 instances of that virtual machine and use each one of them to host an isolate process and use them then from a single Dyalog session running on my laptop. And finally, I'm going to wrap up with a little function or operator actually that went into the version 16 isolate workspace that I'm not sure has been sufficiently publicized. Right, so quick introduction to isolates. Isolates are a way of extending your APL process, hooking into other processes, making it look as if they're an extension to your workspace. So if you imagine that this oval that you're looking at here on the screen is a workspace, and you were to load the isolate workspace and type this incantation, which says make 3 empty isolates, it will appear that 3 namespaces have been created and attached to your workspace. These isolates look, taste, and feel like namespaces, except that although each isolate appears to be an extension of your workspace, it's actually hosted in a separate process. And if you execute a statement inside any one of these namespaces, it actually runs in a separate space. So the ISS variable that was created here is a 3-element vector of references to these 3 isolates. And if we were to type an expression like this, which has been valid namespace syntax, I think, for at least 20-25 years in Dyalog APL, that's a distributed assignment. X in each one of those 3 namespaces is assigned one of the 3 items in the array passed as the right argument. And if we were to dot into the array of namespaces and compute the average, you could have done this with a namespace, then it would be done sequentially. The difference when you're using isolates is that they run in parallel. So when we hit enter on that, 3 computations are done in parallel, in separate processes, and you get the result back as an array. So let's see how that might look in practice. You start by loading the isolate workspace. The infrastructure which creates these isolate namespaces is still an APL model using Conga under the covers to do TCP communications. The hard part of doing a parallel demo is really to think of some computation that's going to take a significant amount of time. What I've done here is I've simulated that we have some stock prices, monthly stock prices, a bit odd I know, but there you go, you can't make it realistic all the time. So here's an array of 8 stocks for 1 year, monthly stock prices. And although we started by generating random numbers and doing a plus scan on them to generate these series, we then doctored the second one to make it a copy of the first one lagged by exactly 1 month. So we repeated the first month of the first series, and then the first 11 months following on that. So the second time series here can be very accurately predicted using the first one, using a bit of math. The math that you need is, well, one way you could do it is to compute the R² statistic of the one series fitted onto the other. And I'm very grateful to Roger Huey for writing this function for me. He remembers much more of his linear algebra than I was able to. And if we try applying that then to, say, the first 11 numbers in the first series and compute the R² statistic, the last 11 numbers of the third series, we get this number. And if we have a perfect fit, we get 1. Unsurprisingly, the second one is totally predictable according to the first. Right, now of course what we want to do is we want to collect figures from the stock market, and then we want to compare every series to every other series and see whether, if we have data for one series, we can predict what's going to happen to another series, and then we'll live happily ever after, having collected lots of money. So we do this outer product. We then look for where we have a very high R² statistic. In this case, we can see it happens exactly once. We can use the new where function from version 16 to get the indices of the ones in that matrix and get a result that tells us, well, stock number 2 is predictable according to stock number 1, or using stock number 1. So that only took a split second. Let's increase the stakes a little bit here. 1,200 stocks for 5 years, and instead of making the second series just an exact copy, we'll add a little bit of noise to make things more realistic. If we now look at the first 2 series, and using drop rank 0, 1, we do a -1 drop of the first series and a 1 drop of the last one. We see now it's not that easy with the human eye to see that those 2 series of numbers are in fact very predictable. The second one is very predictable. I'm going to use a little trick here because we're going to use a lot of memory. When benchmarking, it's often a good idea to make sure that the workspace is fully expanded. Because otherwise Dyalog APL will try to start off using little memory, and then it will gradually grow the workspace as it needs more and more space. And when we do that large outer product, we're going to bang our heads into the ceiling a large number of times as we go up, and that's a fairly expensive process, so it affects the timings anyway. Having fully expanded the workspace, I'm now going to compute these 1,200 times 1,200 R², and that takes about 7 seconds in the workspace. And of course what we want to show you is how you speed that up using parallel computations. So in this case, if we look at the top left numbers of this 1,200 by 1,200 matrix, we can see we have 0.99. We don't any longer have a perfect 1 there because we added some noise. In fact, if we see how many of them are greater than 0.96 now in this large matrix, it's a whopping 61. And that is, of course, because we're also getting lots of hits where a series is predicting itself. So if we add this little jot.not equals selfie to mask out the main diagonal, then we cut it down to 4 numbers. So, you know, the 2, 1 is still by far the best, but we've actually got 3 more that look as if they're predictions, and that's the dangerous thing, of course. So before I continue, I need you to read this statement very carefully. This presentation is not an alternative to financial advice from a professional, and if you try and use any of this, it's at your own risk. Dyalog is not certified to provide this kind of advice. I'm just trying to burn some CPU. Right, so in the isolate workspace, I'm now going to, although my machine has 8 processors, it's actually my hyper-threading. There are really only 4 processors. So I'm going to say I only want to launch 4 processes. I want them to only have a maximum workspace of 256 megabytes rather than the 500 megabytes I have in my own workspace. There's a bunch of configuration parameters that I don't have time to go into. There'll be a link in a moment to talk on isolates if you want to know more about how all the different options and how to set them up. So to create an isolate, we're imagining that eventually this will become a primitive. Creating an empty isolate will be this SOL, or international currency symbol, symbolizing the little sort of remote planets that you're creating. At the moment, the model, the isolate workspace, allows you to use this Scandinavian Ö, or if you prefer, you can write isolate.new to create a new isolate. So what's happened when we did that was that in addition to our dialogue session, we now have 4 dialogue runtimes. I asked to have 4 created, and as soon as you create the first isolate, they are created. And if I just display the isolate in the session, it doesn't tell me very much. It's a bit like a namespace, except it's an isolate. I can dot into it, I can create a variable, I can dot into it and do a little calculation. But the thing you would typically do is perhaps do something asynchronous. So I'm here executing a delay, a 6-second delay in the isolate, and assigning it to a variable called weighted. Notice that that's going to complete immediately. My application can then go on with some of its other business, and then at some point it will do something that requires the value of that future that was created when we executed an expression in the isolate. And at that point, the APL interpreter will simply block automatically until the value is produced. So if we just do that again quickly, I immediately get that back. When this expression executes, it waits until the value has been produced. So that's using a single isolate. Here, of course, we want to use multiple isolates. First, I need a little helper function that's going to split the problem up. So I've written a function called RSQPart, where the left argument is the partition size, and the so that should say omega. The right argument is the offset, so the row at which to start. So if I've got x being 1200 by 600, and I do the size 2 RSQ partition starting at 0, I get back a 2 by 1200 array. And if I use each to execute 4 of those starting at 0, 2, 4, and 6, catenate them together along the leading axis, then that matches the first 8 rows of my result. So I can break it up into little pieces. I then create 4 new isolates now, 4 reshape, passing this time, instead of an empty vector, a list of names that I want to appear in the isolate. So the RSQ and RSQPart functions were transferred there. I'm going to use the same trick inside the isolates to fully expand their workspaces. And in the interests of time, I'm going to skip these next 2 lines and move on. So now, because I'm going to be executing this RSQPart that refers to x as a global variable, I need to transfer my data, which is going to be used multiple times for calculations, into the isolates. I can ask for its shape to check that they all arrived safely. Yes, every isolate contains an x, which is 1200 by 60 in size. And now I can execute my 4 parallel calls to RSQPart. So that took 2.87 seconds, and I'll just make sure my workspace is expanded and execute it in my workspace. So now I'm doing it serially. The previous expression did it in parallel, and we can see that, first of all, the good news, the results are identical, and it ran about 2.5 times faster, which is pretty typical for a modern quad-core computer doing something fairly CPU bound. It's not really 4 times as fast because you have memory contention. Right, so that's the introduction to isolates, and that's been working in that way for, I think, about 5 or 6 years now. Just quickly, a picture of what happened there in the hope that that'll make it completely clear. We had a dialogue application. We executed an expression to say we wanted 4 new isolates. In this picture here, we only have a 2-core computer. So by default, it's going to create 2 isolate processes. It's going to set up some TCP sockets, and then for each one of the isolates that it creates,
it puts them into the least busy isolate process. So in this case, we end up with two isolates in each process. And since version 14, in fact, there has been in the isolate workspace a function called start server, which took as an argument the IP address of a machine that you wanted to provide services to. And if we had used that, then it would have, if it was a 2-core computer, it would also have created by default 2 isolate processes. And if we then call add server on the client to point out to the isolate workspace that there are other machines, or there's another machine willing to host isolates, then when we created the 4 isolates, it would have looked like this. We would have had 1 isolate in each of the 4 processes, 2 locally and 2 remote. So if you would like more background information, go to docs.dialog.com for the user guide on parallel programming, or watch one of several talks at Dyalog user meetings on isolates. There's a link to one of them here. We'll be posting the slides after the talk. Right, so now we'd like to start some remote machines to run Dyalog APL on the cloud. So here comes the bit where I really need to cross my fingers and see if I can do this by hand. Maybe I should increase the font size a little bit here. Right, so what I want to do is I want to create an instance, and the first thing that Amazon asks me to do is to pick an operating system. So I could pick Windows, but I'm going for the free tier. In fact, I think there is a free Windows machine, but I'm going for the smallest thing they have, an Ubuntu server. So I'm going to select that. And I'm going to go, actually not for the smallest machine they have, the T2 Nano, but the T2 Micro, because there's this little green label here that says free tier eligible. And I haven't paid them, I've paid them $3 so far because I made a mistake and selected the wrong machine type, and it took me a day to figure it out. And I had to cough up $3. So it's not very dangerous even when you make mistakes. So we've picked an operating system and a machine size. We need to set up some security groups. Now I've done this before, so I'm going to select some of my existing security groups, opening up holes in the firewall. First of all, I want secure shell access, so I can connect to it with a terminal or from APL using our SSH client. I want to open port 7052, which is the one that I use normally for isolates. And I want to open up port 4502 to allow RIDE access. So having selected those 3 rules, the rules are very typical things you'd set up in a firewall. You have a port range, and you can limit the IP addresses that can be connected to. I'm leaving them open for everywhere. I review and launch my isolate. And so the way you log on, sorry, not launch my isolate, I'm launching an instance of a virtual machine on Amazon Web Service. The way you log into these machines is never using a password typed in. You always generate a key pair, a public and a private key. And in the interests again of time, I'm going to reuse a key pair that I've been using a few times. There was a webinar on microservices in Dyalog APL a few months ago where I think I showed the whole process of creating the key pairs and so on. But now I'm just going to reuse an existing key pair, and I'm going to go and look at my instances, and we can see here that this instance is pending. I have a large number of terminated things from exercising, testing that everything worked. And it's running. See, that didn't take very long. And now I'm going to see if I can install, I think the next thing I need to do is install Dyalog APL on it, because at the moment it only has just the core operating system. Again, the webinar a few months ago showed how to use a technology called Docker, which makes it very, very easy to pre-configure and then load virtual machine images. It's actually so simple to install Dyalog APL, if that's all you need, that I'm not going to bother with that. I'm just going to go through it manually. If I could type the name of my script. Here we go. So, we need to know the IP address, which is different each time. Here is the public IP address of the machine that's starting. It's different every time. You can also set up fixed IP addresses you can pay for, or actually I think you can have 1 or 2 free IP addresses permanently allocated. So I'm now going to create a secure shell session to that machine on port 22. I'm going to create variables containing the names of the private and public parts of the key pair that was created. And then I'm going to say I want to log on to the Ubuntu user ID, which is the default user ID, using this key pair. And I don't want to explain that, but it's a little utility function that processes the result of executing a shell command, because I just get numeric Linux Unicode numbers back, and I want to be able to read them. So now I need to go to a tool called Winscp. There would be many other ways to transfer this to a Unix machine, or transfer a file to a Unix machine. This is my favorite. I need the IP address again. Winscp is a tool that allows me to synchronize folders amongst other things. So I've got a folder here on my Windows machine, and I'm going to copy the Linux installer over to... I should have started that first, because I could have had that running while I was doing the first bit of setup. This would be a good time to ask some questions, actually, or to answer some. Use ncopy. Well, Richard suggests I use ncopy. The problem with that is I would have to mount this machine I just created as a remote file system, and I would have loved to do that but I'm not sure it would have taken less time. No one is asking any questions. Is there anybody out there? Yes. So I've got 41 seconds. Anybody know any good jokes? So the purpose of this Apl Ssh Tool, I can talk a little bit about that, is that it allows you from APL to create sessions on a remote machine securely. So what we're going to be using it for in a moment is to start Dyalog APL running the isolate server machine. And the beautiful thing about it, because it uses this private public key mechanism, is you have the user ID, the Ubuntu here in your application code, but you do not have the password. So the machine has been pre-configured with one part of the key pair, and you have to have the other part on your machine. And when you log into the Ubuntu user, the host system looks to see whether a key matching the one that you're providing is on the machine, and then you're allowed in. So it's considered a very secure way to do this kind of thing. Right, so now the file has been copied, and I can shell out and I can say list whether there are any files called linuxstar.deb, and indeed there are. And then I will run a sudo command to run the installer. So that installed Dyalog APL on the machine. And then I will run Dyalog APL on the machine. And you'll notice I did that with an ampersand. So that started sh in a separate thread, because that command doesn't terminate until APL terminates. So that thread is going to be there, and I can see that it's there while that command is running. I'm then going to go into RIDE, and I'm going to need the IP address one more time. I need to paste it into RIDE and connect. And I now have an APL, that APL session available to me. I can do, what can I do? What's a good thing? Uname -a. I can see that it's Ubuntu, Linux, yeah. So I now have a Linux VM with Dyalog APL installed. The next thing I should do is to right click, image, create image. I'm not going to do that because I've pre-prepared one, and I don't want to risk having made any mistakes in what I just did manually. So I've got two machine images. I've got one which is a JSON server that I used a few months ago for a demo, and I've got an isolate server which is just a copy of what I just created. Right, so we need to shut the instance down. Yes, thanks for the reminder, because one of the things about the free tier is that you can have exactly 20 virtual machines running. And so I need to terminate this one because I want to use my full quota of 20 for the next part of the demo. Right, so right now I've got a bunch of slides here that I was going to use in case any of that failed. There are a few things that I didn't talk about, and that's the pricing. So I can have T2 micros, I can use 750 hours a month, and I can have a maximum of 20 servers running at the same time. That's the free tier that you can sign up for. It only takes a short amount of time, and of course a credit card number. I did accidentally burn $3 once. You need to be a little bit careful if you leave things running. You see, if you look at these, we're running the micro, which if you had to pay for it would cost about 1 cent an hour. But you can rent machines costing, if you go for a memory optimized X1 32X large, which I presume has 32 processors and a huge amount of memory and gigabytes of SSD, it can cost you $16 an hour. On the other hand, you could do a lot of computing with one of those. You could run, 32 instance isolate processes on a single machine and do a lot of computing. The other thing that you may need to pay for if you store anything permanently on these machines is you may need to pay for storage. And there's also a charge for data transfer, rather less than when I started life as an APLer, and I think we paid $1 per 1,000 characters of output. It's now 5 cents per gigabyte, or it starts off at nearly 10 cents a gigabyte. But let's move on. So we've got our instances set up. I had screenshots of all of those. Now, this is where it might all come unstuck. It generally works, but not absolutely every time. I still have a little bit of reliability work before we release. So I'm now going to do the remote demo. So we already have the secure shell stuff loaded. I need to load a class that will be included with the version 17 workspace, isolate workspace, a class called AWS. And what you do there is you make a new instance of it, and then you set up a bunch of parameters, most of which should now be fairly obvious based on the screens we've already seen. So you have to set the user ID you want to log into, where your key files are, the name of the key pair you want to use, the Amazon region you want to use, because you can start virtual machines in Ireland, France, Germany, in the States, in the Far East. So you have to pick the region that you want to run in, the name of the machine image that was saved, the instance type, and there you need to be a bit careful, because if you don't set that variable, it will pick some default machine that actually costs money. The set of security profiles that you want to attach to the machines when they start. And then there's a little utility function that checks what your current IP address is, and we'll be using that because we want to limit the service only to ourselves. So run instances uses something called the Amazon command line interface, and it fires off this command here, run instances, and most of those variables just appear as parameters. The count is 20, the instance type, key name, etc., etc. And if we were to go over to the Amazon console, we could hit refresh and we could see these things starting up. The APL code is going around in a loop, checking the status, and finally after 25 seconds all 20 of the machines are up and running, and we have this nice little matrix with all of their instance IDs and their IP addresses. Now here's the shell command that we want to execute on each one of the machines. We want to call Dyalog APL and load a version of the isolate workspace, and then there are a bunch of settings to say which IP address to accept connections from. Auto shut 1 means that when the first connection that's established is shut down again, the whole server should shut down. The port number to use, and isolate equals isolate, is just a configuration that says we'd like to run an isolate server, please. So I'm now going to launch that. So what that's doing is it's creating a secure shell to each one of these machines using the technique we saw earlier, and running this APL command on each one of them. And to pass the time, I'm going to show you another slide. So what's happening here is on our Windows computer, we have a Dyalog application. We actually started 4 isolate processes earlier. Those are still there. And we have, in fact, at the moment, 4 isolate namespaces. We have that ISS vector still with 4 elements in it. And there's a TCP socket connection to each one. We're now creating, in fact, 2 secure shell sessions to each one of these virtual machines. One which is used to launch APL, and another one which is sort of a command channel that we can use to query the state of the machine if we think something's going wrong. We've got 20 of those. We're going to create 20 isolate namespaces, 20 more, so we'll have a total of 24. So with a bit of luck, that'll be finished. Oh, only 33 seconds. It sometimes takes up to about a minute to start 40 secure shells and log into them and start APL. Of course, if you were going to do a bunch of calculations, you'd only do this once and then you'd use them over and over again. So we got back a vector of processes, 20 of them. We can see the first one has this IP address, and in fact the additional command secure shell is in there as an object called command, and if we use that sh function we defined earlier, we can do things like see which processes are running on the machine that have Dyalog in the command name, and use that if we want to debug what's happening on the machines. But what we want to do is we want to call add server, an isolate function, to say this machine here at address prox number 1 address port 7052 is an isolate server. Go and see if you can connect to that. And that returns the current status of the whole isolate machinery, and we can see that on localhost we've got 4 ports, we've got 4 isolate processes running, and in fact each one of them is currently hosting an isolate, and we've just added this one, and now I'm going to use a little defun with each to connect to port 7052 on each of the remaining 19 processes. That didn't take very long. I'm going to erase those 4 isolates that we were using before. And I set the variable n to 20. I'm adding 4 to that, and I'm now going to create 24 isolates, all containing the function RSQ and RSQ part. And then I'm going to ask for the state of the isolate system, and we can see that we have 4 isolates running on localhost and 1 each on 20 other machines. I'm going to use the expand workspace trick so that they all allocate 256 megabytes of memory. And then I'm going to dot into each isolate and ask it for the first item of the APL version property. And we'll see that that returns 4 times Windows 64 and 20 times Linux 64. So the first 4 isolates are running on Windows on my laptop, and the other 20 are running on Linux. We don't really care because we're executing APL expressions that are entirely portable. If I use the key operator to find the indices in the platform of the ones that are Windows 64 and Linux 64, that's not surprisingly the first 4 and the last 20. And if I use those indices to index into the isolates vector, I can create a local vector of isolates and a remote vector of isolates, take the first one of each, and check that, yeah, indeed, the first local one is running Windows. That all looks very sane. Right, 2400 stocks and new random variation in the second one. So I've been testing this a little bit, and I found out that the 4 processors I have on my local Windows machine are significantly more powerful than the little T2 micro virtual machine instances out there. So what I've decided to do is to use that RSC part function, and I'm going to use a window size of 300 for the local Windows ones, and only send 60 rows at a time to the 20 remote machines. I'm going to be doing about half the processing locally and half of it out on the network. And so with a plus scan I can compute the offsets into X. X is now a variable 140K. I'm dotting into X for all 24 and assigning the X array to them. And then I'm asking for the tally of X in each one to check that they all arrived. So I get 24 2400s back, and that took 2.3 seconds to distribute my data to all of the machines. Show the fish tank. So that's this guy. Drum roll. So I now take the vector of local machines and the vector of remote machines. I could just have used ISS, but I wasn't entirely sure they'd be in the right order. And I've created I now have a particular set of blocks I want computed on individual machines. So local comma remote is a vector of 24 isolates. I call the RSQ part function, passing 1 element of offsets into each one and 1 element of sizes into each one. And the fish tank should go wild. I'm a little bit dissatisfied that it didn't go all the way to 100% locally. It only went up to... Oh, well, I suppose with hyperthreading I actually have more. I only asked for 4. So that takes 7 seconds. I then experimented a bit changing the block size, so giving the local machines only 250 rows and the remote machines 70 each. Compute new offsets. Do it again. And this time it would be a good time to think of questions, because there's going to be a very long wait in a moment. I'm now going to do the entire computation locally, so all 2400 by 2400. Better hit enter rather than keeping talking. You'll now see that very unfortunately we're using exactly 1/8 of the machine according to this, because it's only running serially. A single APL process is doing all 2400 by 2400. And this is going to take about 2 minutes, so does anybody know any good jokes? Are there any questions? So either it's crystal clear or I've completely lost everybody. Oh, that only took 32 seconds. So one of the interesting things about this is just how variable these timings are. I had one, the last one I did before coming online took 2 minutes. Generally they've taken around 100 to 120 seconds. This time, maybe because I shut down Outlook and Skype and Pigeon and a dozen other things, APL is feeling very much happier and managed to do it faster. The important thing is that the two results are the same, and instead of 2.5 times speed up, we got a nearly 5 times speed up. The last time I did it, I had a 20 times speed up, but that's must have been because my local machine was busy. Right, so in fact, very little needed to be done to the isolate workspace to get all of this to work. Most of the work done was the work done by Marinus Oosters to create the Apl Ssh Tool, which was really critical. And then playing around with Amazon Web Services and the command line interface to understand how to launch those processes, how to copy stuff over. There's one more thing I would like to demonstrate before returning to the slides, and that's the parallel each function, which has in fact been in the isolate workspace since version 16, but I'm not sure we really publicized it very well. So the isolates are good when, or sort of work as they are out of the box, when you have a nice one-to-one relationship between the number of function calls that you want to make and the number of processes that it makes sense to start. But very often that isn't the case. You have a very large number of function calls. In this case, I've got 100 function calls I want to make. I want to do quad DL on 100 different numbers. And there's a operator in the isolate workspace called each X, which is in a namespace called LL. And it's an extended parallel each. It takes as an optional right argument a vector of isolates. So in this case, we've got 22 isolates pre-created. They contain all the data that we know our application is going to need. And we want to make 100 function calls to the operand that we provide on the left, which in this case is quad DL. So the X here is the extended version, which will pop up a UI and allow us to track what's happening. And we can see every time one of the isolates comes back with a result, its bar gets a little bit longer. And as soon as an isolate is finished executing one of these functions, it's given the next task to process. So we're recycling these 24 isolates to execute the 100 function calls. And we can see that we managed to do a total delay of 245 seconds in a mere 12.4 seconds, which is a speed up of about 20. So the overhead and the fact that maybe a few of them were left running something at the end when all the others were finished means that we get quite close to a 24 times speed up, because in this case there's no real work to be done. It's just a bit of TCP. I mean, a significant number of messages were sent to Ireland and back to get that to work. So this, in fact, is, I think, about half of the people who started looking at isolates eventually ended up using the each X pattern, because it's a better fit for what very many applications need to do. Right, so it's time to start shutting things down. I'm going to remove the isolate servers on all of the 20 remote machines, call the remove server function. As each one of these loses its connection, because we had auto shut equals 1 set, it's actually going to shut down. And that means the Dyalog APL processors are going to shut down. And this quad T sync here was waiting for all of the threads that were suspended in the Apl SSH exec command on the Dyalog process to terminate. So now all the APLs are terminated. We can pick the first session and look at the output that was collected by the Apl SSH tool. So we can see it started up, said it was listening, started to handle a thread, it lost the connection, and then it terminated. And there's just one thing left to do, and that's to shut down the instances, and that's done using the terminate function, which is in the instance of the AWS class. We pass it that vector of 20 instance IDs in the first column, and it terminates as soon as they go to shutting down status, and then it starts well, no, actually then it terminates. So now we could sit here and watch them all terminate, but that's not really a lot of fun. That's it. So back to the presentation. We've done the LL each X. So to summarize, Dyalog is now taking the cloud and distributed computing very seriously. We've been talking about it for quite a bit, but in the last few months, with the advent of Docker and learning how to fire up instances on Amazon, I think we'll also be looking at various other cloud frameworks. We're really hoping to make frameworks, reference architectures available for you all to do this yourselves. This is actually stuff that you can do at home without much risk. You can control the costs, and the technology is surprisingly easy to use. The Apl SSH client, as I mentioned, is an important component. We've been playing with running isolates. We demonstrated the JSON server, which is our offering for a very simple microservice framework. We're building that out, and within the next month or two, I expect we'll be publishing a reference framework showing how to spin up JSON servers that start background processes if you need load balancing and so on. So DAAS, Dyalog APL as a service, is coming soon. We are planning to publish what Amazon calls premium machine images, where you can, without having a customer relationship with Dyalog, you can rent machines directly from Amazon containing Dyalog APL, and Amazon will collect the money for both the machine itself and the software that you have running on it, and we'll get our share eventually. We're also hoping to publish pre-built Docker images with Dyalog APL installed, maybe with JSON server, my server, and other suitable or relevant frameworks installed. The hardest problem actually is to decide on the pricing. How much should Dyalog APL cost per minute or per hour? But we will sort that out. The time has come. We have to do it now because people really need to hook into these things. Yep, I think that's it. Still no questions. Oh, well, I will take that as a sign that it was very clear. I elect to do that. So we'll hang around a little bit to see if there are any more questions. We've decided that next webinar is going to be about creating and managing your own user commands. We'll be doing some internal training here at Dyalog because there are a number of people who've decided they want to learn how to do this now, and Adam will be doing a webinar once he's done some internal training to share that with everybody else. And then it could well be back to the cloud for the one after that, but we haven't quite decided yet. Really no questions? Ah, well. Okay, well, I hope you enjoyed that, and you can always send us an email if you think of questions after the event. Thank you very much. See you next time.